An interrupt on a computer is an event that causes the CPU to stop doing what it's currently executing and start running a different piece of code. These events can be anything from a mouse click to a timer interrupt, which is necessary, for example, when multitasking in Windows. Interrupts are generally asynchronous. They can occur at any time. So when coding an interrupt service routine, or ISR, to handle an interrupt, there is no room for error. When an interrupt occurs, the CPU stops whatever it's doing and it transfers control to the relevant ISR. The CPU will store, amongst other things, the address of the next code instruction to be run, called the program counter or instruction pointer. Control is then transferred to the ISR via a specific address in a piece of memory called the interrupt vector table. Here, a Raspberry Pi computer is sending a message to a servo motor control system. When the servo motor is ready to respond, it raises an interrupt. This causes the Raspberry Pi to send another message to the servo, which then responds. The ISR itself may want to store more information to process the interrupt. For a key press, for example, the ISR might want to read the key value and store it in a queue for later processing. When the ISR is finished, it returns control to the interrupted code by a special machine instruction which restores the saved PC and CPU state. Different types of interrupts can have different priorities. An ISR may itself be interrupted by a higher priority interrupt. For example, in an aircraft, it's more important that the engine on fire interrupt is given a higher priority than the interrupt that monitors cabin temperature. Dealing with the asynchronous nature of interrupts can be challenging. Writing fast, efficient, and bug-free ISRs is definitely not a trivial task.